Hello everyone. Before we proceed on, I would like to thank Astronomer for sponsoring our today's video. So if you're diving into the world of data, Astronomer's product Astro makes it super easy to orchestrate workflows and manage complex data systems more efficiently at enterprise level. So whether you're a data engineer or someone who's more passionate about data, so you should definitely check out Astros and its features to see like how they can help in transforming your organization's data journey more efficiently. So I would also provide the link in the descriptions so you can explore around Astronomer and its products on your own. Thank you. Hello everyone. So today we have Pragya here for a mock interview session. So Pragya is a data engineer who has 2 years of experience in a data engineering aspect. So hello Pragya, how are you doing?
I'm doing well.
Yeah,
Thank you.
that's great. So, Pragya, with regards to our today's interview session, so we will start ahead with solving two SQL problems, and then we will proceed on with the basics around data engineering, and I would also ask you certain questions around your projects and all, and so and so. Okay. So, Pragya, I have shared you the document link, right? So, can you please share your screen and open the SQL doc?
Sure.
Okay,
Uh,
perfect. So before we get started, I'll just explain you the question, and if you got any doubts, just get clarified on it, and we'll start writing the query. Okay. So here I have given you a SQL data sets. So where I want you to write a SQL query to fetch top five selling products for each day. So when I say about top five selling product, it's based on the quantity. Okay. So here we have three different tables, which is orders and order items. Where if you can see, this table is being normalized, and so order and order item has a relation of like order ID, and product is connected with the order item using the relations product ID, right? So just write a SQL query to get the top five selling products for each day.
mm,
So before starting your query, you can also just discuss about your approach on solving the problem. So if there is anything going wrong, I can just let you know.
so, so I'm thinking of joining, the orders, uh, orders table with the order item table, and then joining that with the product table, so as to get the information about the product name, and like we need to find a selling product, top five selling product for each day. So I'll do a group buy on the order on the um, I'll do a group buy on the on the order item ID, so that I can get the number of count, the number of count, uh, like the number of quantity, and for each day we have to find.
Okay, so as you mentioned, you're going to do a group by operation based on the order item ID.
Yes.
Sorry, the product ID, right?
Yes, on the product ID.
Okay, but the question states that you have to find the top five selling products for each day, right? Then there should be a logic to find the top selling product for each day as well, right? So if you are grouping it based on the product ID, so the product could be sold for one particular day, and also it can be sold on for other particular day. So if you are just grouping it solely on product ID, it's not going to give you the right answer, right?
Yep. So, like I'll group on the product ID and on the basis and on the order date, so that like I have to find for each day. So like I'll do a group by on the product ID and the order date, and then I'll get a quantity the quantity of that product, and then I'll use a like limit function which is in the SQL, and I'll find the top five like limit five.
Hmm. Okay. So here the ask of the question is basically to find the top five selling product for each day. So, how is a limit works in SQL? So, imagine that your SQL query is providing a result of 100 rows. So, if you are limiting it by 5, it's going to only provide you the first 5 rows, right? But if you want to find the top 5 selling product for each day, then I guess limit would not work.
Yeah. Uh, so I'll use a like window function. For example, here rank, and there like in the subquery I'll use a rank function, and I'll calculate and in the upper query so I'll just filter out like where rank is like it's less than or equal to 5, so I will be getting the like top 5 product.
Yeah, that's good. So, I'm good with your approach. You can start write the query.
Okay, so I'll join my like um, product name. This will be coming from my product table, so I'm aliasing as P. Um, then I'll do from orders O. I'll join it with um, orders. Okay, I'll join it with orders item. So I'll give it as Y on the basis of O dot order ID. This should be equal to I of uh, or I'll join it with product table, that is P, and I'll join on the basis of P dot product ID should be equal to O file product ID. Okay, so okay, so I'll use a rank function, and I'll do a by partition by on the basis of um, product ID, order date, and yeah. So I'll do so it will partition the data the basis of product ID and order date.
So I have a question. So why do we really need to do a partition based on product ID?
Because we have to find the like as it is said in the question like top selling product. So selling product like it. it is based on the like quantity, like how much quantity that product has been sold on each day. So every product will be like, for example, the product 101
Hmm.
uh, would be like its quantity sale would be 5 or 4. Same for the product ID 103, it would be other. So
Hmm.
like we have to find the top selling product. So which product quantity has been sold more.
Hmm.
So that's why I'm doing partition on the product ID and the order date.
Hmm. So I think before the window function, I think you forgot to like implement the grouping operations. So you were speaking about it, right? Like first we have to initially group the query based on product ID. So that because like for each day there can be multiple products could be sold on a single day, right? So we have to group based on the product ID, and then we have to perform the rank operations, right? So imagine that there are 10 orders which has happened for a particular day. So within the 10 orders, so I could have the product ID 10 which had repeatedly sold for 5 orders at least. So every order would have its own set of quantities, right? So to get the top selling product of each day, I probably have to group it based on the product, right?
Yes. So um, so basically, what I'm thinking, for example, I have the product ID as 101, and the like today it is being sold the quantity is 5, and like tomorrow its quantity is, so like for every day I'm like aggregating the value, like total like today how much quantity that product has been sold.
Mhm. So try to split the okay. So let's try to split the task into different chunks. Okay. So the first priority for us is to join the three different tables. So we have the informations which has been distributed across three different tables, right? So first we did the joins. So
Mhm.
and for each orders for a single day there could be like multiple products which could be sold, right? To get the actual amount of product which has been sold for a particular day, then probably I would do a group by operation based on date and product ID. So which
Yes,
will
yes.
give me the total amount of quantity which has been sold for a particular product on a particular day, right? So this is my second priority, and the third priority would be to write a window function which is going to rank my product based on the total number of quantities being sold, and from that I would pick the top 5, right?
Yep.
Okay, I guess you got the solution, right? So how we are trying to solve it.
Yes, yes.
Okay, so I think we are above the time, so let's move on to the next question. So yeah, you can scroll down. Yes, so here we have other SQL query to be written for a Uber dataset. So imagine that on a Uber dataset, so we have tables like rides, and the other table is payment transactions. So whenever a ride has been completed for a particular user, he has to pay the transaction, right? So I want you to write a SQL query to fetch the number of rides with incomplete transactions. So when I say about incomplete transactions, so for whatever the ride ID, which is the primary key for this rides table, if you do not find the matching records in the payment transactions, then it means it is an incomplete transaction, right?
Okay. Hmm.
So here we have this ride 1001 and 1002. So for both of them, we have the entry for it in payment transaction. But what if there is another ride ID which is 1003, which is available on the rights table, but it is not available on the payments table? So how do you write a SQL query to identify that particular incomplete transactions?
So, for example, if I have a ride ID as 1003 and it is
Mhm,
not present in the payment transaction,
mhm.
uh, then that right ID would be the answer, right?
Yes. So maybe let me remove that particular record in the payment transaction. So if you see for the rider ID 1002, so we have the record in the rights table, but we do not have it in the payments transactions. So basically, right 1002 is an incomplete transaction. So how do you identify it?
So here I'm thinking of using a left join,
Hmm.
uh, like right left join payment transaction, and like wherever I will get the value as null for the transaction ID, that would be my the right who has not paid the amount.
Hmm. Yeah, go ahead.
Select right ID. This is something not right ID. Mm, right left join payment transactions. And EPT dot right ID where P dot transaction ID is
Okay. Let me also add a new scenario to this question. Let me just add a new record to the rights table. Okay. So imagine you have the third record, which is 1003. So basically, here you have the start time, but you do not have the end time. So a customer would pay his transactions only after he completes his ride with the driver, right? So here, if you can see, the end time is actually null. So by this way, it doesn't mean that the 1003 is not an incomplete transaction. So with the query which you have written, it will also include 1003 as an incomplete transaction, right? So how do you
yes
exclude that?
and R dot and if end time is like is not null. So basically, for the rider who is having the start and the end time,
Hmm.
um, that if that person has not paid the payment, that name would be like his ride ID would be there. But for the person whose end time is not mentioned, like end time is null, so I have written like basically it will filter on the basis, first it will check whether the transaction ID is null, so that would give me 102 and 103. But
Hmm.
even I have written one more filter where it will also check like whether uh, that that rider have the end time or not. Like if it is null, then it will not check.
Hmm. That's great. All right. So do you still want to solve another use case, or we shall move on with the other questions?
Yeah, like we can another,
Okay,
we can
all
use
right.
an.
Yeah, let me just add a new record to it.
Sure.
So here, if you see, I have the start date and end date. Okay, so for the fourth record, which is 1004, for this particular record, I do not have an entry in my payment transactions table. So let's imagine. So instead of so when you book a ride on your Uber, it provides you the estimated time, like where it's from by when your ride is going to complete, right? So imagine that instead of null, you have the start time and the projected end time already been entered onto your record. Okay, but right now your time is actually um, 12:30, which means the current timestamp is 12:30, but your end time, which has been projected over here, is 1 a.m., right? So in that case, this will be like projected as an incomplete transaction, right? So how do you exclude that? Are you getting my point?
Like, can you please repeat again?
Yeah, sure. So imagine when you book a ride on Uber, so it's going to like let you know about the start time, and also it will give you a projected end time. So when you are going to reach your destination, right?
Mm-hmm.
So imagine like the developer has created this table as in the way whatever the projected end time it has been given, it's going to get entered onto the record instead of null. Okay, so your current timestamp is 12:30 p.m., but here the end time is 1 a.m., right? So in that case, the customer wouldn't have made his payment transactions because his transaction is his ride is not completed.
So like you're talking about, like, here it would be 12:30 and.
Yeah. So right now, imagine the current timestamp is 12:30. Okay. So right now you are trying to pull out the report. So in that report, 1004 is also going to be taken as an incomplete transaction, right? But the ride has not completed because the end time is 1 a.m.
Okay, like it is exceeding the end time. Like,
Yes. So how do you exclude the end time based on the current timestamp? So right now it's 12:30 p.m. If it becomes like 1:30 p.m., then it means the fourth record is a complete transaction.
okay.
Okay, so I was actually expecting for an answer where you can add a new condition based on current. If you will check if the end time is greater than the current timestamp or not. So maybe the question was not much clear, but that's fine. Yeah. All right. So let's move on for the basic questions around the data engineering. So you can unshare your screen. All right. So when we come to the big data engineering, so we speak more about this distributed system designing, right? So what is the difference between distributed storage and distributed processing?
So distributed storage basically means that, like, for example, we have a lot of data. When we talk about a big data, it means we have a lot of data which cannot be stored into a one machine or one laptop or computer. So basically, we segregate those data into some like machine. For example, if I have like 1 GB of data, and I'm segregating that data into like 5 different machine, like 5 different machine or 4 different machine is taking 500 MB, 500 MB of data. Like, this is what the distributed storage means. And distributed processing means, like, so like we have data on different machines. So we have and we want to gather the information from those different data, which is from those data which is stored in different machine. So we use some like framework, like for example Spark, to process our data, like as per the business requirement, like whatever the logics we have written, to process those data we use a Spark framework, which is a distributed processing framework.
All right. So do you have any examples for distributed storage? Any idea
Yeah,
on it?
for distributed storage, like we can use like HDFS, that is like Hadoop distributed file system.
Okay. So when you are discussing about the distributed storage, you mentioned that the files would be splitted and it would be stored on a different cluster, right? So how
Yes.
do HDFS keep track of these files? So how does it know like this particular chunk of file is available in particular folder?
So basically, it maintained like metadata, like name node. So name node is there, which collects all the information, like on which data nodes we have data, like what type of data is present on which data nodes. So name node, like it store all the metadata about the data stored, like which data is present on which data node and which data node has been failed. Like for example, it can be possible that any of the data node can be failed, so it maintained those information by interacting with the data node. It maintained those information like where the data has been stored.
Okay, perfect. So let's move on with the Spark framework. So with Spark framework, so we have a concept called as RDD, dataset, and data frame, right? What is the difference between three of
So RDD is basically a low language processing Spark processing. So RDD basically means that like resilient distributed dataset. The full form is resilient distributed dataset. So RDD, so like basically it is the low level operation we do on the Spark data frame, and it is also like it is not optimized as well. Like for example, like we use map and flat map function, yeah, or reduce by key, so that function we use in an RDD. Whereas on data frame, it's a high level uh, uh, like programming, and it is more optimized as compared to like RDD. And like basically when we write our code in data frame or the data set, basically it works under the like RDD. And the difference between data set and the data frame is that, so whenever we write our code, like for example, if there is any like data type mismatch, or any column name is being not written properly, or it's written wrong, so that information is given when we use a data set. So like whenever we write our code, so if any data type or the column name is not matching, like we can see, like whenever we are writing the code, we can see that it is giving an like error issue, like it's giving a warning that this line is being, it's not written properly.
all right? Okay, yeah. So like when you're speaking about this RDD, right? So it's a resilient distributed data set, right? So why that word resilient came? So how exactly the data set is been resilient?
So whenever we write our Spark programming language, whether in RDD or in our data frame, so internally when we execute our code, internally Spark like it creates like DAG. So DAG is basically like whatever the transformations we are using, for example, filter, where, or join operation, whatever the transformation we are using, it basically uh, like whatever the steps we are doing, it basically take the information. Like for example, if any of the like for example, if I have written a code in RDD, and in RDD3, for some of the reason the RDD3 value has been like it lost, so it is basically recovering the, so basically it will look into the DAG, like what transformation is being performed, and it will basically do like whatever the transformation we have performed in order to calculate RDD3, it will process that. So that's why it is said as resilient, so that like it is like fault tolerance. Like if any of the code is not executing properly, or if any code value is being lost, for like RDD value is being lost, it can recover that from by seeing the DAG.
Okay.
So that's why it is resilient.
Okay, so let's speak about the functions in Spark. So, are you aware of this? coalesce and repartition?
Yes.
Yeah, can you please help me with the difference?
So basically, when we want to like, for example, I have many partition and I have to reduce the number of partition. So in that case, we use a coalesce. So coalesce basically it doesn't shuffle our data. So repartition can also be used to reduce the number of partition, but in repartition it allowed shuffling of the data. But in coalesce it does not allow shuffling of the data. So whenever we want to reduce the number of partition we use a coalesce, and whenever we want to increase the number of partition we use a like repartition function.
Okay. So you spoke about shuffling, right? So what is shuffling and when does it occur?
So shuffling basically means that the data is being shuffled from one machine to the another. And shuffling basically occur, like for example, if I give you an example, like when we do a group by when we use a group by function. So group by basically means that, for example, if I am doing a group by on the basis of name, so it can be possible that our data is being distributed on four of the machine, and my name would be possible that it would be in the data node 1 and it would be in the data node 3. So basically I have to group the value, like how much money I have spent, so I have to group the value. So the data has to be like it has to be shuffled or it has to be transferred from one to the another so as to get the aggregated. So whenever use a group by or join, the data is being transferred from one machine to the another. So that is what shuffling means.
Okay. So how do you monitor if your data from whatever the piece of code you have written and your let's say like your application is running on your production systems or anywhere. So how do you monitor like what are all the operations is being performed by Spark? So how do you monitor it?
So basically, we use a Spark UI to see like what all transformations we have used and which transformation is taking more time. So by seeing the Spark UI and by seeing the logs which is generated on each, like when we see a Spark UI, we can see that like if we have used like 4 to 5 action, so it can, like we can see like on which of the action it is taking more time. So, like from the Spark UI, we can monitor our Spark.
Okay. Okay. So like since you have mentioned that you have looked on the Spark UI, right? So there is a concept called as stages, jobs, and task, right? So
Yes.
what is can you explain three of them?
So let me start with the tasks. So tasks is basically means, like for example, I'm writing my word count problem, and in that word count problem I have used multiple of transformation. For example, like transformation can be of two type, like wide and narrow transformation. So for example, I've written map, then filter, then again I've written reduce by. So map, filter, reduce by, this is my task, like individual tasks is this. And stages is basically like whenever we use a white transformation, like a new stages is being created. Why new stages is being created? Because a data is being shuffled, so a new stages is being created. And action basically like job basically means like how many actions we are calling while writing our Spark program. So for example, if I'm using like 4 or 5 action, then my job would be equal to 4 or 5. And stages would be equal to like how many white transformation I have used plus one. That would be my stages. And tasks basically means like what individual, like map, filter, or like the narrow transformation which we are using. So it would be the like that would be our individual tasks.
Okay, maybe I'm not convinced with the answer for task, but that's fine. So, like you spoke about transformations and actions, right? So, what are all the functions which contributes to transformations, and what are all the functions which contribute to actions in Spark? So, just give me some
Um,
examples.
so transformation basically is reduced by key, filter, map, map, flat map is the transformation. And action is our like count, collect, save as text file. That is our action.
So, like, what are all the different write modes which is available in Spark?
So different write modes, like we have an append mode. So basically append mode means like For example, I have the data, like I have saved my data in a file, and again on that file I'm appending some more values, so that is an append mode. We have like overwrite mode also. So basically we have some data and I have to override that data, so we can use an overwrite mode. I am only able to recall two of them.
Yeah, no problem. All right. So I'm good with the Spark related questions. So let's move on to Git. So within Git,
Yes.
okay. So within Git, so we have like commands like git merge and git replace. So what is the difference between both of them?
Git merge and git rebase. So git merge basically means that whenever we are uh, writing our code and we have moved it to a like for example in the production, like whenever we push our code, whenever we push our code, someone would review our code, and then if the code is like, if the code looks good, so then we git merge that with the main branch. So
Hmm.
that would be a git merge. And git rebase, sorry, I'm not aware of git rebase.
Yeah, no problem. So have you ever faced the challenges of conflicts when you're trying to merge your feature branch with master branch?
Yes. Like for example, like in my last project, basically the issue was that like I haven't pulled all the code from our like GitHub. So there was a conflict. So like for some of the like whatever the code I have written, for some of the line, like the function I have used or the function, it was not matching with the code which were present in the main branch. So there I faced a like git conflict.
Okay. So how do you resolve that? So is there any automated way, or how do you actually do it?
So basically like I have compared that with the main branch, and then I have manually
Okay. All right. Okay. So let's move on for the next set of questions. So, what is a CI/CD process, and why is it more important in the software development lifecycle?
Manoj, I just have a basic idea of CI/CD.
Yeah.
So basically, it means like continuous integration and continuous development. So, for example, I can give an example like to explain. For example, if we take an example of Facebook, so in Facebook we have like every 6 or 5 like 1 year we have some new features coming in Facebook or Instagram. So basically, the developer who are writing the code, they don't want that the application gets stuck in any way. Like for example, they are merging their new code, they don't want that their application would get shut. So basically it's like they're continuously developing the code, and they're integrating their code with the production. And also they are like having that like their current like their current application is not getting destroyed or shut in any of the way. So
Oh,
there we use SCI.
okay. Yeah. All right. So let's move on for the last set of questions, and we'll wind up this interview. So let's go on for the cloud fundamentals. So what is your understanding around serverless computing, and what are all the advantages of using a serverless computing machines?
So serverless basically means like whenever we are using some like any of the services, like for example, if I give you an example of AWS Glue, so we don't have to set up like the user don't have to set up that we require this amount of like cluster or this amount of code we need. So that means like it is a serverless. So yeah, so that is serverless.
Okay. Have you worked on like creating a glue job from the configurations?
No, like
Cons-
I've just used a glue to read the like metadata.
I see. I see. Perfect. All right. So I guess we are good. So let's wind up the interview. And thanks a lot for your participation, Pragya. And I really wish you all the best for your upcoming interviews. And I hope like we shall meet again in the new mock interview session. Thank you.